Alright, well, we're back now to look at 7.4, which are our rules of replacement, section 2. As we learned previously, with the rules of replacement, this new symbol of the double colon means that whatever is on one side can be replaced with whatever is on the other side, and it doesn't change the meaning, it doesn't change the truth value of the statement, it's not going to affect the logic of your argument. So we have the last 5 rules being presented to us here, whereas the first set of 5 dealt with the dots and the wedge. This one is going to deal primarily with the horseshoe, but also the triple bar. And so we have transposition. Transposition, trans, says that if you have a straight conditional statement, P then Q, it can be replaced by reversing that and negating it. So instead of P then Q, it becomes not Q, then not P. This makes sense if you think about our basic modus tollens rule, right? If P, then Q. If not Q, therefore not P. Material implication, impl, says that if you have not P, then Q, that is also exactly the same as not P or Q. So a straight if P then Q is the same as not P or Q. Now keep in mind, of course, we can also go the other direction on any of these. It simply depends upon what you need in working the equation. Material equivalence is the only one that deals with the triple bar. Remember, the triple bar implies that P and Q are the same in value. They're either both true or they're both false. When I introduced the biconditional to you originally back in chapter 6, I used this as the example, basically, that it's a conditional that works both directions. So essentially, if P then Q and if Q then P. Right? So if P then Q and if Q then P, it works both ways. But it can also imply P and Q or not P and not Q. And again, if you think about it, what is that triple bar? It means that they're both the same value. They're either both true or they're both false. So either P and Q, the true, or not P and not Q, the two false. So in any event, we can replace the one side with the other as needed. Exportation, exp, says that if you have something like this, P and Q in parentheses, then R, you can export it, and that makes it P then, and then Q then R in the parentheses. What's happening here is that, just like in associativity, you're shifting the parentheses from one side of the equation to the other. The difference is that with the exportation, that initial dot is being replaced with the horseshoe. Okay, so that's exportation. And the last one that we look at, you already probably can understand this one right away, and it's the only one that doesn't deal with the triple bar or the horseshoe here in this case, but it's the tautology, taut. And it basically says that if you have two of the same letter joined by either the wedge or the dot, that it's reducible to that same letter. All right, so if you have P or P, that's exactly the same as P. If you have P and P, it's exactly the same as P. Of course, this one is also essentially just simplification, but this one is not, because you can't use simplification on the wedge. So in any event, if you see the two letters that are the same joined by either the dot or the wedge, the tautology allows you to reduce it to that singular letter. And so anyway, just like I did the last time, we're just going to go ahead and jump into some of the problems, because the main issue here is just getting you somewhat familiar with the basic ideas. And so at 7.4 section 1, which in my book is on 429, we have our first problem, which is H or F in or not S, not G or Q, And then line 4, we're supposed to figure out what we can draw from that, and they want us to use impl, which is material implication. So we look at material implication. So we're going to be looking either for a conditional, or we're going to be looking for a disjunctive with the first letter being a negative, not P or Q. Well, there's no negative on that one, so that's not going to work. Technically, we could use either lines 2 or 3, but the straight view, the one your book would want you to use, would be line 3, not G or Q, not P or Q. Not P or Q is if P then Q. So not G or Q would become if G then Q. Because your book insists upon commutativity, it would want a second step in there to use line 2. But actually, commutativity, like I said, is one of those steps that can easily be waived visually. And so technically this could be not S or N, which would make this if S then N from line 2 as well through material implication. So in either case, that would be workable. Let's look at another one. Number 2, we have R then S then N. Line 2, T then U or M. Line 3 is K and L then W. And line 4, they want us to figure out, they want exportation. So exportation, again, we're looking for either P and Q then R with the parentheses on this side, or P then Q then R with the parentheses on this side. Line 1, they're all horseshoes, so it looks kind of like P then Q then R then S then N, which means that this could be made to look like this. So that would be R and S then N from line 1 through exportation. Line 2 is not going to work because it has the wedge in there, and the wedge is not part of exportation. Line 3, the dot is not inside the parentheses, so that's not going to work. So it has to be line 2. Okay? So that's all there is to it. And so I'm going to let you go ahead and try the rest of those for homework as well. So 7.4, section 1, 3 through 15. Like we did on the last one, I'm going to go ahead and skip past the section 2 part, and we're going to move on to section 3, working the proofs. Again, I'm not going to make an overly big deal out of this, but at the same time, it is something that needs to be done. So we'll just have you do a few of these, but I'm going to do the first one with you. So we've got S and K, then R. Line 2 is K, therefore S, then R. Well, quite honestly, if I were doing this, I would simply take line 1. You've got S and K, use simplification. It becomes, keep the S, get rid of the R, it becomes S then R from line 1 through simplification, and I'm done. That's the easy way to do it. That's how I would do it. But this particular section wants you to practice these different rules, so there's another longer way of doing it that's going to incorporate these rules. So what we'd have to do, I guess, is to look at what we have here, S and K then R, and see if one of these forms matches up to it. Now I see exportation, P and Q then R. P and Q then R becomes if P then Q then R. S and K then R would become if S then K then R. But that's not what we want. We want S then R, right? So we would want to use an actual commutativity here. In this particular instance, it would be necessary to do that. It would become K then S then R from line 1 through a commutativity of the S and K to K and S. Then, using exportation, K and S then R would become if K then S then R from line 3 through exportation. And then lines 2 and 4 make a modus ponens. If K then S then R, K therefore S then R, 2, 4, modus ponens, and that one is proved. Okay, so basically it's not an overly difficult prospect, but it does take longer than the way I would have done it. But nonetheless, that's the way they would want you to do it here, because again, the idea is to try to use these new rules and become more familiar with them. Once again, I don't make a big deal out of the rules of replacement, so I'm not going to give you a lot of those, but I will have you again do 2 through 5 just to get a little bit of practice on that. Alright, so basically the homework for this section, 7.4, you have section 1, you're going to do 3 through 15, and for section 3, you're going to do 2 through 5. Right? And I will be back with videos working through the solutions to those so you can check yourself, and as always you can either send me an email or use the discussion board if you have any questions about anything throughout the week. Don't forget office hours are 9 to 10 Monday through Friday, so you can email me or write on the discussion board at any time during that time period, and I will get back to you pretty quickly. Alright, so we'll see you in a little bit with 7.5.